All right, so here we are at sea level. The weight of the atmosphere exerts a pressure of 14.7 pounds per square inch, commonly referred to as one atmosphere of pressure. Now, as an object descends in water, pressure P and depth D are linearly related. In salt water, the pressure at a depth of 33 feet is 2 atmospheres or 29.4 pounds per square inch. And we need to find a linear model that relates pressure P in pounds per square inch to depth D in feet, interpret the slope, find the pressure at a depth of 50 feet, and then find the depth at which the pressure is 4 atmospheres. All right, so what we need to do is we need to first come up with an equation. So what does it say? It says at sea level, which would be 0, it's going to be 14.7. And then what we're going to do is we're going to say, okay, well, we're going to look at this as, even though this is a depth of 33 feet, we're going to say, well, that's going to be, 33 feet down, and that's going to give us what? 29.4 pounds per square inch. Okay. So we're thinking of how far below it is. It's 33 feet below, but we're not going to say it's a negative 33. We're just going to say it's 33 feet. Now, so if we plug this into our calculator, then let's see, where's my calculator go here? All right, so we have something from another previous one. So, oops, we want to edit, clear that, clear that. So now we have a 0, and we had 33 feet, and then we have 14.7 and 29, 29.4. Now we do our stat calc 4. Let's put that into L1. So vars 1. All right, so it looks like we have an equation of, now if we go out to say 3 decimal places, it'd be 0.445x plus 14.7. So let's do that. And we want pressure in terms of depth is going to be equal to, and if we do 445D plus 14.7, that's going to give us pounds per inch squared. Okay, so basically, the pressure is going to be what? So it's interpreted slope. So our slope is this. So the pressure rate of change is uh, the pressure rate of change is 0.445 pounds per inch squared per, and this is going to be in D, which is in feet. So that's going to basically happen. So the pressure is going to go up 0.445 pounds per square inch for every foot you go down. All right. Now find the pressure at a depth of 50 feet. Okay, well, that means we're going to find P of 50. Well, instead of doing that, let's go over to our equation. We've got it in y1s, so let's get rid of that one. Go over here. Now we have this. And so what we need to do is we need to, oops, not that, second trace a value at 50. And we get 36.97. And let's see, what units did they want and what pressure. It doesn't say. So let's put 36.97. And that's going to be pounds per inch squared. And maybe let's, I don't know, if we round it to 1, that's going to be about 30, wait, did I say 37.97 or what did I say? I better look at that. I thought I said 36. Yeah, 36.7. Oops. Erase that. That's a 6. So 36.97. So that's roughly 37 pounds per inch squared when we round it to 1 decimal place like they have here. All right, so then the last one, find the depth when an atmosphere is 4, or when the pressure is 4 atmospheres. Well, two atmospheres is 29.4. So it's going to be four is going to be two times that. So we're going to have two times 29.4 is equal to 0.445D plus 14.7. And let's just plug that into the calculator. And that looks to be, if we round it, the depth is going to be roughly 99 feet below sea level. Okay. So notice I didn't use negative numbers or anything else. I just said, okay, it's that far below. And so then a pressure of 50 feet below gives us this. And then I have to take two times this to get this to be four. So if I take that times two, I have to take that times two. And that gives me that pressure. And then I just solve for D and I got my 99 feet below the sea level. All right. So let's stop with that one and come back for another.